Hi folks, this video is about the periodic table of elements. First off, what's the purpose or the importance of the periodic table? Well, it takes all of the elements that we know and it organizes them into an easy to read format. Since all matter in the universe is made up of a combination of these 118 elements that we know of, it becomes very useful for scientists, especially chemists, to be able to look at different elements and their properties based on this table. Dmitry Mendeleev is the guy who is credited for coming up with the idea of the periodic table. He was born in 1834 and died in 1907. His table was a little different than the one we use today, but it was a very, very good system that he started us out with. And in fact, it was so good, there was an element that had not been discovered in his country of Russia just yet, but somebody claimed to have discovered it in France. And the French guy published a paper about that particular element and had its density in there. And Dmitry came along and said, listen, I've never seen this element before, but based on my periodic table, it says the density should be this. And it turned out that Dmitry was much more correct than the French guy. So this is why we use this table today. It's very useful for finding all sorts of things, and we'll learn. So first off, in each square, we call those element squares, each element has a square on the periodic table. That square includes the name, the symbol, atomic number, and atomic mass of that element. So the name is just the full name of the element. This example is hydrogen. The chemical symbol is the shortened 1 to 2 letter abbreviation that we use for the name. And its first letter is always capital. So for example, we have like helium over here, even though it's 2 letters, the first letter is capital, the second is lowercase. We also have the atomic number, which you know is the number of protons that the atom of that element has. Each element has a different atomic number because each element has a different number of protons. And it's always a whole number because you're not going to have like half of a proton. And then we have the atomic mass, which is how much 1 mole of that element weighs. A mole is the chemist's term for 6.022 times 10 to the 23 atoms or particles. It's usually a decimal because there's a whole lot of math that goes into how we do that, but generally it's about the same as the mass number, somewhere in the same area. And then there's some geography of the periodic table. We have the up and down columns that are called groups, or also sometimes called families. So everything in a column together is related in some way. And then we have the rows, which are left to right, and we call those periods. This is where the periodic table gets its name, the periodic table. So as you go from left to right and you look, when you are a part of a family here, you have a lot of similar things about you, like the alkali metals, the first column here, they are all very reactive with water. But when we read the periodic table, we go from left to right and then down, just like we would a book. So it becomes a periodic trend that we see. Every so many elements, the same kind of properties show back up. The elements, if you haven't learned already, are ordered by their atomic number. So we have 1 here, 2 is there, 3, 4, 5, 6, 7, 8, etc., etc. Those atomic numbers go up by 1 each time from left to right, just like you would read a book. There are 3 main types of elements. We have the metals, which is all of this brown area here. All of these are metals. That makes up most of the periodic table. Most of all of our elements are, in fact, metals. They're usually shiny, ductile, and malleable. They're often good conductors of electricity and heat. They're usually pretty solid at room temperature, and they're found left of this solid zigzag line that you'll find on most periodic tables. We also have the nonmetals, which is almost everything else. That includes hydrogen over here, even though he looks like he'd belong to the metals. He's actually a nonmetal. Nonmetals are usually dull or brittle if they're solids. Most of them happen to be gases at room temperature, though. And they are found to the right of this zigzag line, except for hydrogen, who's over here. And then right on that zigzag line, we have what we call metalloids, that based on the situation they're in, they could act as either a metal or a non-metal. It just kind of depends on what's going on around them. And then I'm going to make a very important point here. We've learned about atoms that they have protons, neutrons, electrons, that protons are positive, electrons are negative, and when they exist in equal amounts, there's no overall charge, and that's what an atom is. At any time when we have more protons or more electrons, it's no longer technically an atom. It's an atom that has a charge, and we call that an ion, I-O-N. So anytime we have a non-equal amount of protons and electrons, say for instance we have more protons than we have electrons, we'd have a positive charged ion. Or if we have more electrons than we have protons, we'd have a negatively charged ion. But it's still the same element. And then some other data that's not readily evident on the periodic table. It's not part of the element boxes, but you could graph this. There's a wonderful website from the Royal Society of Chemistry that has graphed this for me. But density, you can see here these little colored bar charts for each element is how dense each element is. So you can see that most the elements get more dense towards the middle of the periodic table and down. Osmium is the most dense element on the whole periodic table. We also have atomic radius. That's basically the size of the atom. Remember, atoms are kind of spherical, so if you find the radius of that sphere, the bigger the radius, the bigger the atom. These get bigger, the atomic radius, the atoms get bigger as you go down and to the left. So as you go down a row, the atoms generally get bigger. And as you go over to the left, francium here is the biggest atom that we have. And just a couple other things to note. We already mentioned this, but the atomic number is ordered from left to right. The atomic mass follows that same trend most of the time. It gets bigger when you go down, but it usually gets bigger when you go from left to right. You can see that here, like 40, 44, 47, 50, 51, 54. So that's 58.9, then it goes back down to 58.6, 63. So most of the time it gets bigger from left to right, but not all the time. And then we didn't mention this guy down here. These are our lanthanides and actinides. Those are our very radioactive elements. Most of the time we pull those out of the periodic table. They actually all belong right here. And that would make this whole periodic table much longer than it is, and it wouldn't really fit on the screen very well. So we usually pull it out to the bottom and just put them down